This video describes the process for calculating the hill slopes and average altitudes for the terrain factors used in MsTower. This is based on the method outlined in Annex J of BS 8100 Part 4. The process uses the KML profiles obtained from Google Earth and converts these to CSV files, and then uses a Python program to calculate the slope and altitude. Now this is just a draft method at the moment, and it needs a bit of verification and simplification. But this is the Annex 4, and it shows the profile, the low altitude height, the average, a line above that again, point D here for the initial slope, and then calculates the final slope. Now we start with Google Earth. Now I've used a Google Earth add-on program called it's a circle calculator program. You input the latitude and the longitude in decimal format in degrees, and you input the radius of 8 kilometers, and that creates a Google Earth file, which is what I've done here. So this is the site location. This is actually Belhaven Lough in County Leitrim. This is the site location, and this is the radius of 8 kilometers all around. Now then we use this add path function here. So we click on that, and we may need to change the color maybe to a red, and we change the width maybe 4, and that then draws gets profiles from any point to another point. So if we click on the center here, we can drag in any direction we want. We drag the cursor along, say OK to that. This creates this untitled path file. We right click on it, show the elevation, and that's the profile along the 8 kilometers. Now I'll just close that down for a second. I will take one in particular, say along this direction, about 225 degrees from north. So again we go add path, click on the site, drag the cursor in as straight a line as possible, say OK, right click, show the profile. So this shows the profile here, starting around 275 meters, sloping down to about 72 meters, and back up at 8 kilometers to about 240 meters. Now we can check the initial slope, which seems to vary here. We can see 12%, maybe on average 12%. So if we just check what that is in degrees, it's 0.12. Inverse tan is 6.8 degrees initial slope. Now where the slope hits the low point here, from there on, the average altitude, we can just make an estimate of, it's a low point of 73 up to maybe 240, 250. So it might be an average of about 130, 140, that kind of order, just to give us a feel for where we're at. So we save that, save place as a KML file. Change that to KML, and we'll call it, so that we'll remember what direction we're looking at. We'll call it BEL 225 because it's 225 degrees from north, 7 because 7 is the initial slope approximately, 140 because 140 is approximately the average altitude. So we save that, close that down a minute. Now I use a program called TCX converter, which converts the KML file to a CSV file. So we open the KML file, and that creates this shows this data here, which is the latitude, longitudes, and all the altitudes are set to 0 from distance 0 down to 8.1 kilometers. So we need to sort out the altitude. So we go track modify, update altitudes. Now we need an internet connection for this, so we say yes to that. That just takes a few seconds there to update the altitudes. Okay, so now the altitudes are pulled into this from 274 at 0, drops down to maybe 66, 72, 71, at around 3.6 kilometers from the site, and 254 at the 8 kilometers. So now we save that as a CSV file, so export to CSV, and that creates the same file name with CSV. Now we need to say no to this because it's in the Python program that I'm going to use. It needs cell separators and needs commas as those. We say no to that. Now if we look into the folder, we see the CSV file here, which is this one here. If we open that, we see it's basically an Excel file with a lot of information, some of which we don't need. We need the latitudes, the longitudes, and the altitudes, and it's got about 58 points on that, so we can close that back. Now I use the slope calculator Python file to calculate the final slope and the average altitude based on Annex J. So we open that up, and it asks for a file name, so we put in BEL225_7_140.csv, and that creates this graph. Now we'll just pull that out of the way. It also puts in the final altitude here, or the final altitude and the slope. The slope is 6.79 degrees, and the average altitude is 130.9 meters. That's calculated based on the info in Annex J. We'll just pull this out a bit better so we can see it. It shows a graph here based on this from the CSV file, which is, you can see is quite similar to the profile in Google Earth. And it also calculates a number of things. This is the initial slope based on the slope of the points on the profile. This is the low altitude line at the lowest altitude. This is the average altitude, and this is the line at the same height above the average altitude. This point here is point D from Annex J, which is where the slope hits the low point. This line here is the 18 times h site minus h average, which you see isn't really that far from the site. And then it calculates the final slope from the hill top to the point within that distance. So it's actually pretty similar to the initial slope, just because this example doesn't really have any curves within that. So that's basically it in accordance to Annex J, and we can do that for as many directions as we like in Google Earth. It might be just interesting to look at a different direction, say the north direction. So if we take again at path go north, say okay, and we see the profile this time. The slope initially from the site position goes up to a peak of about 394 and then goes back down. So if we were doing this, it would probably be better just to take the profile from the peak to 8 kilometers out, because otherwise it's going to try to calculate a slope from here, which would be an upward slope rather than a downward slope. So it might be better just to take the peak from here. It'll calculate the slope from downhill from here, and then we can manually put in an x value of 1.76 kilometers from here to the hill.